let's work through number 20. The diagram below shows an angle theta graphed on the XY coordinate plane. Segment RT, let's just stop and look for that one. There we go. RT is right here. Is the initial side of the angle. Segment RM is the terminal side. And segments RT and RM are radii of the unit circle, and that is important, and my ink pen's not wanting to cooperate. Unit circle, which means that the radius is 1, and that is important to know. So the first time I read through this problem and worked through this problem, I thought, oh, there's not enough information, and I realized there is because they said it's a unit circle. So this length is 1, as is this length right here. This ink pen is not cooperating, so I am going to switch ink pens. And I'll try this little Sharpie pen right here. You didn't need to know that, but now you know. Let's keep reading. The x-coordinate of point M is -1/2. Okay, well, so what do we do with that information? Well, not much. Let's just put it. There we go. Now, what's the y-coordinate? I don't know. Actually, you can very easily figure it out by using, here's the fun part, you could use the Pythagorean theorem on this. Now, if you're thinking, Mr. Reader, my mind didn't go there, I would not have thought of all that, I'm already lost. Don't worry, let's try it all again. You have an angle. They tell you that this is 1 and this is 1, and they tell you an x-coordinate. That's all you need to know so far. So let's just keep reading. What's the measure of theta to the nearest thousandth of a radian? Okay, we're dealing with radians here, not degrees. So we need to make sure that whatever we do in the end becomes in radians, or happens in radians. So here's where my mind goes as I look at this problem. I realize that I need to find this entire angle in radians. And I think the best thing to do is just take this in pieces and not do it all at once, because that's a little overwhelming. Like, how am I going to do this, and how does this information play in? Let's just stop for a second. You know that the top part of this is 180 degrees. So if we find this, we can add 180 degrees to it and get the whole thing. Now, I know they say radians. Let's talk degrees. Let's do degrees first, and then we'll deal with radians, okay? So I'm going to find this measurement right here. Let me switch pens again and try the one I just tried. I'll use a different color. Let's use, yeah, right. Same color. Let's find this angle right here. And this angle is basically this little part of the triangle. What triangle? What about triangle? Well, I know I need to know this angle, so let's just draw this over here so you can visualize it a little bit better. And because they said unit circle, we have that much. And also because they gave us this coordinate, that coordinate, which is -1/2 comma something, we know that this is 1/2. The distance is 1/2, right? Now, if you're like, oh, but it's -1/2, let's just deal with distance. Okay, don't complicate your life. And I'm looking for the measure of this angle. And when I'm done, I'll add 180 degrees to it. And again, I'm dealing with degrees. We'll convert it to radians when we're done. That'll just be the last thing we do. All right, let's go back to Math 2 for just a second and do some stuff that you already know how to do. If I am going to find the measure of an angle and I know a couple sides, I can use trig. This leg of the right triangle, here's your right triangle. This leg of the right triangle is 1/2. This is the hypotenuse, and it is 1. This leg is adjacent to the angle. Because it's adjacent, we will use cosine. Cosine of x degrees is 1/2 over 1. Well, dividing by 1 is one of the most pointless things you could ever do with your life. So we're just going to move on without the 1 in the denominator. And the cosine of x is equal to 1/2. Okay, great. Well, if I wanted to solve for x, I would do an inverse cosine. If I'm looking for the measurement of an angle, I do the inverse operation. And so I'm going to type that into Desmos and find it. Now, again, I'm in degrees. I'm not in radians. If you want to do this in radians, you can. You can go ahead and do this in radians because anytime you are in Desmos, you are automatically in radians. So let me kind of demonstrate for you using this very old iPad. Click the gear. You're automatically in radians. Right? This is an older version of Desmos, by the way. But it'll work. So I'm going to figure out what the inverse cosine is. So I'm going to type it, and you can really just literally type the word inverse cosine, and I'm going to raise it. This would be so much easier if I was using a computer. Well, actually it's not, because I tried it and that video didn't load. So here we go. Inverse cosine of positive 1/2, but I thought it was negative. Don't worry about that. And I get this right here. I get 1.04 1.047, and that's right. It's not wrong at all. If you want to do degrees, you can. But since we're automatically in radians, I think we can stick with that. Now, up to this point, I've been talking degrees, but let's stick with radians, okay? So we have this many radians. Normally, when we talk about radians, we use pi with it, but this time I'm not going to, and I got 1.047, and that's great, and that's just this part. However, if I want to know the full measurement of this entire angle, I would add 180 degrees to that. Well, this is not degrees, right? This is radians. So, radians. So instead of adding 180 degrees, I will add pi radians. So I'm going to go 1.047 plus pi, and just so I don't have to use the clunky Desmos, I'm going to grab my calculator very quickly, and we'll type it 1.047 plus pi, and I got 4.189, and that corresponds to option B. So let me go ahead and tell you on this one, it is so easy when you're taking a test to get discouraged or to spend a disproportionate amount of time on one problem. Do not waste your time spinning your wheels, so to speak, on a problem like this. Move on and come back to it. Sometimes moving ahead on a problem, skipping a problem and coming back gives you a fresh perspective when you come back to it.